section about Spot and how News Corp use Spot to replace RIs. And so, introducing our speakers, we have John Matheson from News Corp, who's the Cloud and Automation Manager, and he's interested in all cloud-based savings and opportunities and efficiencies. He's travelled to over 40 different countries, which I just found out about 2 minutes ago, which was very, very interesting. And we also have Jared Speaker, the solution architect, and he's an enterprise solution architect with a bit of a focus on Spot, complex migrations and automation, focusing on media and entertainment customers as well. I'm also a fan of baseball and apparently on some list for hacking. I've toned that down a bit from the original response. But you know he's a good solution architect when he's also a hacker. So flicking over to the other slide deck, I'm going to hand it over to Jared and John. Thank you guys.
All right, thank you everyone. Thanks for showing up today. I won't stand in the way of the presentation, but yeah, as mentioned, I'm Jared Speaker. I'm the solutions architect that looks after News Corp, part of the global team really. News Corp is one of our global customers. And John is in charge really of the whole cloud and automation team. So the way that News Corp build out their workloads is they have essentially teams of developers and run on a you build it, you own it type of mentality. So they're also expected to support those workloads. But to provide that governance layer on top, we have John's team essentially provides all the automation and governance around their cloud workloads. So what I'll do today is, you may have seen in the press last year and then a couple of weeks ago as well when you had your annual results, there's a lot of cost cutting and a lot of cost optimization that needs to occur at News Corp. Last year and this financial year as well, they're retargeted with exactly the same goal. We need to shave $40 million worth of expenditure from the overall budget of News Corp as a whole, not just specifically their IT, but obviously IT forms a big portion of that. And so anything that we can do to cost optimize for them around that to help meet that goal means that we can then free up budget and resources to allow more workloads to potentially migrate across to the AWS cloud. So one of the aggressive things that News Corp were thinking of to be able to do this is like, we're already using reserved instances and we can make a lot of cost savings using reserved instances, but can we even shave off more cost? And so we've had the bit of the internal goal over the last 12 or so months to let's see what reserved instances we can replace with Spot instances to really lower our overall expenditure on EC2. So I'll just go through a bit of a Spot 101 for if you're not really familiar about what the Spot market is. Spot market is where AWS or where customers can really bid on the unused AWS capacity. So when we build out our regions and our availability zones, we obviously need to put a lot of computing infrastructure in there, but not all of it is in use 100% of the time. And that unused capacity, we can often sell and actually get people bidding for that use and allow customers to essentially pay cents in the dollar on that infrastructure. The only trade-off with that though is if someone actually comes along and says, I want a on-demand instance, and that capacity within those Spot markets becomes constrained, your Spot instances may be terminated after a 2-minute warning. So what will happen is that, say there's a full fleet of Spot instances that are running, and someone says, look, I actually need an on-demand instance. We will then say, whoever's got the lowest bid on one of those Spot instances, we will put a notification through to that server, say you've got 2 minutes to wrap up your work. After that 2-minute period is up, then we'll shut down that instance, terminate it, recycle it, and then provide it to that customer that was requesting that on-demand instance. So therefore, workloads that are running on Spot, because the Spot instances can be transient and they're a lot more volatile than what you would have for an on-demand instance, we need to ensure that the workloads that are running on those instances are fault tolerant, and we need to be able to restart those at a later time. So some key tenets there is you need to ensure that the applications that are running on them, you're not storing or persisting state on the systems themselves, you're storing that persistence elsewhere, and if you've got a fault-tolerant and a scalable application, these are the types of applications that are more suited towards Spot instances. So within a Spot market, prices will actually fluctuate over time based on the economics of supply and demand. When you, sorry, I should go to the next point. When you actually place a bid for a spot instance, you'll place a bid on that capacity. Now the bid could be at the market rate, it could be above the market rate, generally won't be below the market rate because you won't be successful in fulfilling that instance. But the key point though is regardless of what bid rate you actually put for a spot instance, you will actually only pay the market rate, not your bid rate. So it's an important tenet to remember, and we'll illustrate a little bit later why. But essentially, the mechanics work that that market rate will actually fluctuate over time. And when that market rate goes above your bid rate, that's when you get that 2-minute warning to wrap up your work, and then that instance will be terminated 2 minutes later. But key takeaway here is that we have a large number of different instance classes and different types, or instance family and instance sizes. We also have different levels of capacity across different levels of different availability zones. We also have different levels of infrastructure in different regions. So each instance family and each instance size, each availability zone and each region is all a separate spot market. So just to, I guess, illustrate that is if I was to place a bid for a M4 large instance in the availability zone A of the Sydney region, that is a separate market from instances that are in availability zone B, and a separate market from availability zone C. And all three of those markets have their own separate market price that will fluctuate independently of each other. Here's an example. So here's a chart that we've actually seen. This is the last 3 months. I pulled this out yesterday afternoon, and we can see what that market price has been over the last 3 months across 3 different availability zones. Now I should say we map availability zones differently in different accounts. So this is if you replicated this, you might see different colours for the different lines because the mapping of availability zones in your account may be different. But ultimately we can see here that the AP Southeast 2B, we've had a lot more volatility in that spot market. We've had relatively low amount of volatility in this AP Southeast 2C market, and we've seen a medium amount of volatility here in the Southeast 2A market. But what we see here though is because you pay for the market price, you see your on-demand price is up here, and your reserved instance price will actually be around about this level here for this particular. I think it's an M4 2 extra large. Yep. So that's where your 1 year partial upfront reserved instance price will actually be. So if you're actually using a spot instance, you're paying that market rate, which is generally a lot less than what that reserved instance rate is. And so that's where the mechanics come in. But let's say I had an instance that was in this 2B availability zone, but I set my bid price at this, let's say at the 25 cents per hour mark. If I had an instance in 2C, I would have gone the whole 3 months without being interrupted. The problem is if I went and deployed it in this 2B availability zone, I would have been interrupted here, I would have been interrupted here, here, here. Every time that the blue line gets above that mark, I would have been outbid. And each of those would have been time where I would have been given 2 minutes to wrap up my work, and my instance would have been terminated. So and this goes back to ensure that your application that you're working on Spot are stateless. We can actually handle volatility with actual instances going up and down, and why auto-scaling sort of tends to flow nicely. But how can we also minimize that volatility there? And this leads up to an important topic around diversification. If you look in stock exchange markets, and if you're investing in the stock market, you're encouraged by financial advisors to diversify your investments, because if there is an impact on one of those markets, your entirety of your investment is largely shielded, barring massive stock crashes and nuclear testing potentially in North Korea. You're largely protected against individual events that affect one particular stock that you may be invested in. So I'll just pull up a graph for a different instance type. Instead of the M4 2 extra large, I'll look at the R4 2 extra large, which has the same amount of compute resources, it has double the amount of memory, it's roughly comparable on cost. And the history of this is quite interesting, because we've got the same kind of pattern, but only more recently. Whereas if you look at the M4, we had this really high fluctuation at the beginning, 2 or 3 months ago. Whereas more recently we've had some more fluctuation and more volatility with this particular market. So if there's a way to actually diversify our use of spot instances across multiple different instance types, as well as availability zones, we can provide additional resiliency and insure ourselves against the volatility of spot markets. And this is where our thoughts with News Corp were along the lines of, okay, if we can get this appropriate diversification in place, we could potentially start moving more workloads, even production workloads, across the spot instances instead of reserved instances. So this then brings us to a concept called Spot Fleet. Spot Fleet allows you to launch many spot instances with just one API call. We've got customers that will launch 1, 2, or even up to 3, 6, 10,000 spot instances at any given time with one Spot Fleet call. Spot Fleet allows you to select whether you want instances in the cheapest market or you want to opt to diversify across a wide range of markets to reduce your impact of volatility. And this is the key point that we have here. This diversification option is what we're using at News Corp to maximise the availability of our applications. There are other features of spot fleets that are really useful for scenarios where, say, you're running containers. Weighting becomes a really good mechanism then to scale out based on the number of cores or the amount of memory that you're wanting in a particular cluster, or latency if you're looking after network resources and so forth. So these are some of the other mechanisms that are also available within spot fleets. So now we'll start talking about some of the challenges, though, that we face when trying to deploy spot fleets in a production context. So the first one, I'll talk to the ones that AWS have solutions for, but we've got John here to really talk a little bit more detail about some of the mechanisms and the development that News Corp have done to address some of these challenges. So the first one is with regards to an ELB registration. One of the drawbacks with spot fleets is that they're not auto-scaling groups, and so an instance will not automatically register itself with an elastic load balancer or an application load balancer. And so this, a quick Google search or a quick search engine search will actually reveal the solution to this problem is to use the EC2 user data. So this is metadata that's executed when an instance is first provisioned, and we can use that. It add a simple AWS CLI command to be able to register an instance with a particular application or elastic load balancer. The second challenge that we also face is what happens if this is a public resource and I need to attach an elastic IP address to it. For example, if there is a proxy server that is running or a NAT server that needs to be running, we need to attach an elastic IP address for outbound communication. And so again, the solution here in this case is also to use EC2 user data here. But it's a little bit more complicated this time around. Because first we need to allocate an address to our VPC. And there are all sorts of limits around that you may need to be careful of. So, but then there's also potentially the challenging of deallocating that address if an instance becomes terminated. And then once you've actually allocated that address, you need to also be able to then associate that elastic IP address with an instance. But
you can also use the public addressing space. But however, that's VPC-wide.
Yeah, so there is a feature within a VPC where you can just enable auto-assignment of public IP addresses. The trouble is that's across an entire VPC, and you may not want that across every instance in the VPC. For instance, a lot of customers have a VPC subnet structure where you've got public subnets and private subnets. It'd be nice if you could just say only assign it to the ones that are in the public, or the subnet that we allocate and define as public. And so this is where the close relationship that I've had with News Corp as their solutions architect. I've been working with the service team on adding this as a product feature request, and 90 to 95% of the new features and service features and service improvements that we come out with is based off customer feedback, and it's based off use cases such as this that allows us to go back to our service teams and improve these services, add features based on customer use cases. So another challenge is, okay, in an auto-scaling group, it all works very nicely. An instance gets scaled down and it gets automatically deregistered from an elastic load balancer. But again, spot fleets aren't in auto-scaling groups as such. And so the challenge here is, how do we deregister a terminated spot instance from an elastic load balancer? And an important nuance to that, in addition to how we do that, how do we test this? Because I can't just simply go in and simulate that 2 minute shutdown warning on a spot instance. So when I've actually built this mechanism, how do I actually put it into test? And so we need a mechanism to ensure that an ELB traffic through a load balancer is not actually hitting an instance during that process while it's actually being terminated. And importantly, a lot of customers will do the following. They'll run a script that polls the instance metadata locally for if a termination type has been specified. And again, this is a well-documented process. There's a lot of different Stackdriver and the like pages that will actually show you how to do that. It's a rather complex cron script that will run. Typically, people will run it every minute or so, or even multiple times per minute to poll the local instance metadata via this string here. And then once it actually determines that there has been a termination time set for that instance, we'll actually run a CLI command to dereg the instance from the load balancer, and that will stop traffic getting directed to it. But that doesn't really give us a mechanism for testing. So again, I'll pass on to John. How they specifically handle this.
Yeah, so that case didn't really take into consideration manual terminated events. So if you have a user in the console pushing the buttons and so forth, and it doesn't test, and we want to think a little bit bigger about how we deal with these solutions going forward. So we ran down the Lambda function part. So we created a function that will deregister the instance upon its termination. Essentially, when the EC2 is terminated, the instance state notification is raised in the CloudWatch event, and the EC2 instance change state triggers the Lambda function, which will deregister the instance from that moment forward.
I should say this was plan A.
That was plan A. Alternatively, you can use a CloudWatch event to routinely execute a Lambda function that will come across and do whatever that deregistration event is, or termination event that you're after. This is what we've actually utilised. The function would need to check the instance was terminated and then do the deregistration. But how do we ensure that the requests don't get directed to the instance after it's been terminated? Well, we utilise the health checks of the ELB and the ALB, and we also, on the termination notice, we poison the health check.
So the important concept to grasp there is that while the tried and trusted online, or I wouldn't say tried and trusted, but the typical online solution that a lot of customers will actually do is they'll use that 2-minute warning to actually then deregister an instance. What we're doing here, though, instead, is we're using that 2-minute warning to intentionally poison the health check. And we're using existing ELB health checks of that instance to determine whether an instance is up and running. And so if you've got a ELB with the standard configuration, a standard configuration will do a health check on each server once every 30 seconds, and it will do 3 checks before it will flag an instance as being unhealthy. Even if you poison that health check at the 29-second mark, at the 59-second, if you poison that health check at the 29-second mark, first failed health check will happen at the 59-second mark. The second failed health check will be at the 1 minute 29, and the third one will still be at 1:59. So you've still got 1 second left over with your default ELB settings. You can change them and reduce that window and do health checks more frequently, or not use so many failed health checks to be able to kick an instance out of the pool.
That is if you actually get a 2-minute notification point, which is not guaranteed.
Which is not guaranteed. And this is where, again, where that potential problem is if you're relying on that 2-minute notification warning. You can find some edge cases where you might not receive it and you might not be deregistering, and that can have an impact on your users. By relying on ELBs to health check, you've got a lot more resiliency and a lot more reliability with what hosts and what instances your traffic is being redirected to. So another challenge was around spot price variability. And how do we actually manage those peaks and troughs throughout the marketplace. So yeah, what happens if the spot market price goes up beyond our bid price, and how do we actually handle that? And so this needs to be considered if we're to have any guarantee of service, especially if you've got a small fleet. The more volatility that you've got there, the greater of an impact it's going to have an impact on a greater percentage of the instances that you've got running. So the typical story is, okay, let's just handle the outage and run on demand, or run on demand instances in parallel. Not the best solution. I mean, the whole idea is we're trying to get away from running on demand instances that we can back from a reserved instance, and we want to move towards spot. So deploying diversified spot fleets help to try and mitigate some of the volatility that you will get due to fluctuating market prices. But yeah, as I mentioned, running on demand, it's not really the best answer here. And we ask, well, surely there's a better way. And
yeah, so again, yet another Lambda function. So we're going to preempt the market in this case. And the reality is we monitor the eligible instant pool count. So every spot fleet request has an eligible instant pool count, which is basically the number of pools that you have left available to fulfill your spot fleet request. So we monitor those with CloudWatch alarms. When the pool count drops and you say you've got 2 left, we can trigger a function from that moment forward. This will be the point in time that we start looking to scale out our on-demand instances.
yeah, the challenge is a lot of News Corp's pre-production and development workloads use T2 instances, and T2 instances do not exist in the spot market. So what happens if we have a workload that runs on T2 instance types? So, a typical workaround is, I might need to use M3 mediums. They're really the smallest, or even M1 instance types to be able to use those small instance types and take advantage of that. And so our answer is just use the larger instance types. And deploying spot fleets across a diverse range of pools means that you're not constrained by a particular instance type. And it's very rare that you actually find a workload that doesn't perform as well, or if not better, when you give it more resources. But what about cost? So let's look at an example here. T2 small instance type has an hourly rate for on-demand in the Sydney region of 3.2 cents per hour. The instance features a single but burstable vCPU, and you're given burst credits which you can't exceed. So once you've used all of those burst credits, you're then pegged at the baseline rate for that instance. So you're not getting access to a full dedicated virtual CPU. Secondly, the instance type has 2 gigabytes of memory. So let's compare this with an M3 medium. M3 mediums give you a dedicated virtual CPU, as well as almost double the amount of memory, 3.75 gigabytes of memory. That red line there is what our hourly rate is for a T2 medium. And so even if we're using a T2 small rather, even if you're using an M3 medium in the spot market, there's not a stage where any of this market price has actually gone up above that on-demand rate for a T2 small. Over the last 3 months, I should say. In fact, the M3 medium in the spot market hasn't even gone above 2 cents per hour over that last 3 months. And our average hourly rate in the most expensive availability zone still ended up being 1.28 cents per hour, well below the 3.2 cents. So you've got more predictable performance, more memory at 40% of the cost, using a larger instance type in the spot market. Let's go a bit further. Let's compare it to an M3 large. Because again, we've got diversity across different instance pools, and we can use different instance types. Can we still make a saving with an M3 large? Well, the answer is yes, we can. Here we've got 2 dedicated vCPUs and 7.5 gig of memory. In all 3 AZs of the Sydney region, the market price of an M3 large has not exceeded 3.18 cents. Yes, we're 0.02 cents cheaper at all times in the last 3 months. But further diverse. So if we built this spot fleet out and we wanted to save cost over our on-demand rate of a T2 small, we could use M3 mediums across all three AZs. We could use M3 larges across all three AZs. And we still would have had, even for every single hour, we would have saved over the on-demand. And certainly our ongoing savings, based on the average hourly rate across that period of time, would have been significantly less than a T2 small. Next question is, how do we automate this? How do we get our developers to start using this? And how do we communicate this across to our developers?
Talk to Jared.
Talk to these guys. That's what these guys do. I'll make you talk to this one because there's some... this obviously needs to be considered. It's not much point having a central governance team saying, oh, we want to go down this, we want to go down this way, without having buy-in from developers. Developers do need to make changes to what they do. They need to ensure that their applications are stateless. They need to ensure that they're choosing the right instance types. We need to ensure that there are guardrails and appropriate mechanisms in place to ensure the resiliency and reduce the volatility of their applications that they're deploying via these mechanisms. So this is where the News Corp automation team really steps in. So the advantage to using some of the CloudWatch events and alarms and triggers of Lambda functions is these can all be centralized within a single account. You can use a trigger to call a Lambda function in a different account in CloudWatch events. So essentially we're just deploying these Lambda functions as a single bit of code in a single account, reduces our management footprint, especially a large organisation such as News Corp, where you've got a few dozen different AWS accounts. You don't have to go replicating this automation in every single account. Makes it a lot more difficult to administer and to manage. The team have also spent a lot of time actually working through the complexities of building out spot fleet requests in CloudFormation stacks as well. Something in the order of about 25, 26 different support tickets that we've had through to get additional expertise. We've found problems along the way. We've even had some issues that have been needed to escalate through to the service team for additional guidance and additional feature requests that need to be implemented going forward to be able to satisfy all the, not absolutely mandatory and required capabilities for this solution, but some of the desired features that they're looking at implementing. The key thing though is they have built a mechanism though to translate the existing CloudFormation templates developers are familiar with working with to convert them from an auto-scaling group based template to a spot fleet based template. So it takes a lot of that thinking and that planning out of the hands, or not so much out of the hands, but it means the developers don't actually have to consider it. The idea is that they can build auto-scaling group templates the same way that they always have, gets passed onto the News Corp automation team. They'll pass it through a tool which will then convert that auto-scaling group template into a spot fleet template. And also, given the recent launch of CloudFormation stack sets, there's currently thoughts about how we can leverage those for cross-account stacks and how we can actually improve this automation as well. So we can talk about the solution going forward.
Yeah, so how do we do it, right? So basically we use Bamboo, and inside Bamboo, as Jared alluded to, so we have a standard CloudFormation template, a base template that we start from. And that template has an autoscale group, ELB, baked in. It's a standard bake and deploy process. Security group, subnets, all the usual. We'll have to then call the conversion tool Lambda function. That actually builds our base skeleton spot fleet request. We then have another function that handles our bid types. So we'll make a call to it and we'll use the instance type that is specified in that base CloudFormation.
Sorry, I was going to say, and with regards to the bid price, because we have the goal of saving costs over what a reserved instance would provide, the bid price that we're using this function for is to calculate what the effective hourly rate of a 1-year partial upfront reserved instance is, so that if we can set our bid price at that mechanism, at that level, we know that if we are going to exceed that price, well, we've got functionality to spin up on-demand instances in that case, and we're paying effectively at that on-demand rate for that particular period. But the idea is that those on-demand instances are only running for an hour or 2 hours at most for a short period of time. then over time they will be switched off in favour of spot instances again. And so again, because you're paying for this market rate, even though our bid rate is set to the effective hourly rate of a 1 year partial upfront reserved instance, that is a mouthful. Yeah, that's the cost target that we're hitting, we're aiming for, and that's where we're setting our bid price for whatever size or instance types we're using in Spot Fleet.
Yeah, so basically,
I just said that because,
no, but basically,
as I said, 1 year partial upfront reserved instance is a effective hourly rate for a 1 year PURI is a mouthful. It's something we always struggle with.
Well, yeah, that's right. But the result that comes back from this, which you're wondering about, it provides not only the instance type that we specify, but every other instance type in the families going forward. So this is where we built our, this is where we get our diversification for our Spot Fleet template from. With that information, we then make another call to a different Lambda function. This builds our end state template that we push into S3, and we do the create stack from that moment forward. Now, after we've initiated that, it looks like this. Essentially, we have an elastic load balancer with the Spot Fleet request. The instances will spin up. And in the user data, they'll log in and they'll register up into the ELB as we talked about earlier. If any of the instances are outbid or there's a health issue, essentially what will happen is the health check will be poisoned and the instance will be marked for termination. We have a CloudWatch event that runs every minute that's actually triggering another Lambda function, and the sole purpose of this Lambda function is to actually query each account, look for ELBs that have unhealthy spot instances, and terminate those spot instances. Once one's terminated, obviously Spot Fleet will regenerate a new host, and it will obviously be registered back into the ELB.
A key point there, though, is if you've got diversification. If you say need to run 4 instances and you're diversified across 6 markets, and one of the instances that you've got running gets terminated and is no longer eligible to draw instances from, Spot Fleet will provision the 4th instance again, but from a different market. One that you are under your bid rate is above the market price for.
Yeah, so the next scenario might be is if you're running out of Spot Fleet pools to fulfill your Spot Fleet request, and how do we deal with that? So we use the CloudWatch alarm that's monitoring the eligible instance pool count. And when that pool count gets to 1, so we only have 1 pool count available to actually fulfill those requests, start the on-demand process. So it'll start spinning out the on-demands at that point. We also have one other CloudWatch metric, which is for a perfect storm scenario that we were in at one point or another. And it's where a fleet was partially launched. Essentially, it was what was called a pending fulfillment state. And this is you didn't have a full fleet launched. And this alarm was put in place so that if we were in that state again, we could then just start launching on-demand instances. It's essentially the catch-all at the end.
Yeah. So one of the interesting edge cases that we came across, I mentioned there was a whole bunch of edge cases that we came across when doing this at the level of scale that News Corp is doing. We are doing this at the level of scale that we're using this at. There is an initial limit for the maximum number of spot bids that you can put in place in any account at any given time, and that's 50 bids. And so if we need to spin up more than 50 bids, or you can hit up against that limit. And then what will typically happen is when you've hit that limit, Spot Fleet will go into a pending capacity state because it's wanting to provision additional capacity, but it's hitting that limit and it's not allowed to place those bids. So having this mechanism means that, we have since increased the limit, it's a soft limit, but having this mechanism in place means that in the future, if they hit against that limit again, we've got a mechanism still to ensure there's enough capacity to fulfill the workload, even if it means running on-demand instances for a short period of time.
Essentially, there's also the inverse of these. So if we needed to, if we want to fail back to Spot Fleet, it's just the reverse, right? So if we start having spot, if the eligible instant pool counts come back and we have 2 or more, we'll start scaling back the other way. Downgrade the ELB. Oh, sorry, the auto scale group.
So this leads to a whole set of recommendations that we recommend to adopt a solution such as this, outside of building out this automation around spot fleets and actually using spot fleets themselves. There's a couple of development and deployment recommendations that we do have. The first one I mentioned before, need to build stateless applications. If your instance is going to be terminated potentially with 2 minutes notice, any state that you're storing on the system itself needs to be considered ephemeral. You can persist that data elsewhere. So use DynamoDB, use RDS, use Aurora, EFS, Elasticache, S3, anywhere else. Just don't store that persistent data on your EC2 instances. Poison application health checks. Within that 2 minute warning period, you'll get a lot more graceful failover from your applications between your fleet, between servers within your fleet. It allows you to more gracefully handle termination events throughout your fleet. And finally, set your bid price appropriately. This is a very hard lesson learned in that there is a willingness, let's try and set our bid price as low as possible to maximise, to squeeze out every penny. The trouble is, by doing so, you're going to increase volatility because there's going to be more times the market rate is going to go above your bid price. So therefore, it's a little bit, you won't be saving absolutely every single cent that you're possible by doing a really low bid price instead of a high bid price. A high bid price might cost you 1 or 2 cents more, but given the sacrifice that you need to make and the reduced volatility that you have as a result, is it really worth it? Is it really worth drastically increasing the level of volatility in your fleet to save an extra couple of cents per month? Probably not. So our recommendation is to typically set an appropriate bid price. In News Corp's case, we're wanting to make a saving over the effective hourly rate for a reserved instance, so it makes logical sense to set that as our bid rate. Because we know that for the majority of time, we're going to be paying less than that, we are going to be making a saving, and that's what our goal is. Finally, there's some reference material that we've got here. We can share these links through the group afterwards, or if you look at the video and write them all down, I should put QR codes there. But yeah, that really concludes the talk that we've got today. If you've got any questions, feel free to fire them our way. Yes?
Are you running a lot of workloads that aren't web-based applications using this methodology?
Are you?
Yes, we are.
Don't look at me.
Yeah. No, the answer is yes, we are.
Okay, cool. What sort of other workloads are you running using that?
Help.
So I think it's around analytics. So in this example, they had an ELB, but we also take into consideration ones that don't have an ELB. So a lot of let's call them just workers. So
Yeah, batch processing.
yeah,
Batch processing. I think it's
a lot
like
of that.
ETL type
So
jobs
this
and
was
so
just
forth.
one of the examples. An ELB, obviously a web server, but
We are running production workloads in this, and we're at about about 25% of the overall fleet is converted over to this. It makes sense in a lot of cases, and it doesn't make sense in cases.